Okay, please look at this circuit. So in this circuit, there are two capacitors, right? One is this 0.2 farad capacitor, the other one is this 0.5 farad capacitor. We also got this resistor whose value is what, 10 ohms, and through the resistor the current is what, IR. In fact, the question is what, to find IR as a function of time at steady state. And how many sources are driving this circuit? Clearly two sinusoidal current sources are driving this circuit. One is what, this 5 cos 3t on the left. The other current source driving the same circuit is what, 2 cos 5t amperes on the right side. Okay. So first of all, you should note that both the sources are not at same frequency. Do you all agree with that? Both the sources are not at same frequency. This current source is what, 5 cos 3t. So what is the frequency of this current source? It is at 3 radians per second, whereas this current source is what, 2 cos 5t. Is it not at 5 radians per second? This one is at 3 radians per second, whereas this current source is at 5 radians per second. Both the sources are not at same frequency. See, if you are doing analysis in the phasor domain, we should replace every element with its impedance. For example, both the capacitors should be replaced with their corresponding impedance values. Okay, but how do you calculate the impedance? For a capacitor, impedance is what, 1 by j omega c. So the point is what, impedance of a capacitor or the impedance of an inductor, both are functions of frequency. Yes or no? Impedance of capacitor, impedance of inductor, both are functions of frequency. But here both the sources are not at same frequency. So if you want to replace, let's say, this capacitor with its impedance, then what frequency will you consider while replacing the capacitor with its impedance? Will the frequency be considered to be 3, or will you consider it as 5? So there we have a conflict, which means what, when we do the analysis in the phasor domain, we definitely cannot have both the sources active at the same time. If both the sources are active at the same time, and if you are doing analysis in the phasor domain, then you do not know what frequency to use while calculating the impedance of any capacitor. So here there is no other option but to go for superposition. So here we should use what, superposition. Only then we can do the analysis in phasor domain. Okay. So what is that superposition? We should conduct two separate experiments, where in each experiment only one source is going to remain active. So for example, in the first case, only this source will be active. Then we will find the phasor current through this 10 ohm resistor. And in the second case, only this source is going to be active. Again, we will find the phasor current flowing through the resistor. Okay, so let us use superposition to find the current through the resistor as a function of time at steady state. Okay, look at this. I hope you have copied this down. So case 1, let's say 5 cos 3t, it is what, active. So what are the two sources in the circuit? One is 5 cos 3t, so let it be active in the first case. The other source is what, 2 cos 5t. We will make this source 0. Okay, so this source we are going to make it 0. I'll just write it, 2 cos 5t, right? 2 cos 5t will make it 0, meaning it is going to remain inactive. It will remain inactive. Okay. Now what is the operating frequency? Because 5 cos 3t is what, active, the operating frequency has to be 3 radians per second. Operating frequency has to be 3 radians per second. Okay. Now 5 cos 3t, would it not become 5 at an angle 0 degrees amperes in the phasor domain? Yes. And at the 3 radians per second operating frequency, what is the impedance of this capacitor going to be? 1 by j omega c. Omega is what? 3. C is what? 0.2 farad. I'll just write 0.2. So 3 times 0.2 is what? 0.6. 0.6 is what? I think 3 by 5. So 1 by j is what? Minus j. So minus j 5 by 3 ohms. Okay. So in the phasor domain, this 0.2 farad capacitor should be replaced with an impedance of value minus j 5 by 3. Okay. Minus j 5 by 3 ohms. We should also find the impedance of this 0.5 farad capacitor. Again, that would be 1 by j times omega c. Omega is what? 3. C is what? 0.5. Again, 3 times 0.5 is what? 1.5. 1 by 1.5. 1.5 is what? 3 by 2. So 1 by 3 by 2 is what? 2 by 3. So is it not minus j 2 by 3 ohms? Correct, right? Yes. So the impedance of the other capacitor is what? Minus j 2 by 3 ohms. And by the way, let this current be what? Capital IR1 in the phasor domain, because this is what? Case 1. Let this current be IR1. Capital IR1 is what? The phasor current flowing through the resistor. Remember, this current source has become open. Is it not current division here? Because if you observe, this is one impedance. Let it be Z1. This is what? The other impedance. Let it be Z2. And what is this current? It is 5 amperes, because 5 at an angle 0 degrees is what? 5 amps. So if you observe Z1 and Z2, Z2 is what? The series combination of the resistor and the 0.5 farad capacitor, because this current source is what? 0 or open. These two would be in series. Okay. So this impedance and Z1 both are in parallel. Parallel across what? Current source. Two impedances in parallel across a current source, what takes place? Current division will take place. Okay. And we want to find the current IR1. IR1, is it not the current flowing through Z2? Yes. So current flowing through Z2, would it not be proportional to Z1 in case of current division for two impedances? Current in one impedance will be proportional to what? The other impedance. Okay. First, okay, IR1, capital IR1. First you write the current that is getting divided between the two impedances. The current that is getting divided is what? 5 amperes. So 5 amperes into current through Z2 will be proportional to what? Z1. Z1 divided by Z1 plus Z2. That's all. So will it not be 5 times Z1? Z1 is what? Minus j 5 by 3 upon Z1 plus Z2. Again Z1 is what? Minus j 5 by 3 plus Z2. Z2 is what? Series combination of these two. Series, just add the two impedances, 10 and then minus j 2 by 3. So in the denominator, the LCM, is it not 3? LCM is what? 3. So if you take LCM and so on, I think you will get minus j7 plus 30. 3 and 3 will get cancelled. 5 into minus j5 is what? Minus j25. Minus j25. Minus j25 divided by 30 minus j7. Minus j25 divided by 30 minus j7. This is what I am getting. Okay. Again, this minus j25 can be written as what? 25 at an angle minus 90 degrees. Similarly, 30 minus j7 can also be written in what? Polar form. Can someone tell me what is this ratio in its final polar form? Please tell me. Anybody? What is capital IR1 in its final polar form? So this turns out to be 0.811 at an angle minus 77 degrees amperes. That is what IR1. I hope it is clear up to this point. So this current is due to which, this current is due to which source? It is due to this 5 cos 3t amperes. Similarly, there will be another current component through the same 10 ohm resistor. Because of the other current source, we have to find the other component. For that, we should write case 2, where only this source is going to be active and this source will become what? Inactive or 0. Okay. So now we have what? Case 2. So let me have the original circuit here. So this is what? The original network. So already in the previous case, this current source, it was kept active. Now we should make it 0. Now if you want to make it 0, it becomes what? Open, and this current source is going to be active. What is 2 cos phi t in phasor form? Is it not simply 2 at an angle 0 degrees amperes? Yes. So this time, what is the operating frequency? What is the operating frequency now? Is it not 5 radians per second? Yes or no? 5 radians per second. Again, at this new operating frequency of 5 radians per second, we should find the impedance values of both the capacitors. Okay. So 1 by j omega c. Omega this time is what? 5. C is what? 0.2. What is 5 into 0.2? It is 1. J into 1 is what? J. 1 by j is what? Minus j. So this 0.2 farad capacitor will become an impedance of value minus j ohms. The other capacitor is what? 1 by j omega c. Again, omega is what? 5. C is what? 0.5. 5 times 0.5 is what? 2.5. 1 by 2.5. 1 by 2.5 is what? 2.5 is what? 5 by 2. 0.4 minus j 0.4 ohms. Okay. So the impedance of this capacitor is what? Minus j 0.4 ohms. That's all. Now you see, let this current be some capital IR2, because we are doing analysis in the phasor domain. Every current will become what? A phasor current. And this current, of course, is what? 2 amperes. So look at this. Is it not one impedance Z1? And look at this thing. There is what? Another impedance Z2. So if you notice here, Z1 and Z2 both are in parallel. Z1 is what? Just this 0.5 farad capacitor, whose impedance is what? Minus j 0.4 ohms. Whereas Z2 is what? The series combination of the capacitor and the 10 ohm resistor. And Z1 and Z2 both are in parallel. And then this 2 amperes, is it not going to get divided between Z1 and Z2? So part of this 2 ampere current will flow through what? Z1. The remaining current will flow through what? Z2. So if you look at the direction, so this 2 ampere will split into what? 2 parts, one like this, another like this. In fact, this current is same as what? IR2. This current is same as what? IR2. So IR2 is actually what? The current through Z2. Again, current division. Current through Z2 will be proportional to what? Z1. So in this way, let us write the expression for capital IR2. Again, which current is getting divided between the two impedances? It is the 2 ampere current. So first you write down 2 amperes times IR2 is what? Current through Z2. It will be proportional to what? Z1. So into Z1 divided by Z1 plus Z2. So 2 times Z1. Z1 is what? This impedance, which is minus j 0.4 upon Z1 plus Z2. Z1 again is what? Minus j 0.4 plus Z2, which is 10 minus j. Again, 2 into minus j 0.4, I think is minus j 0.8 divided by 10 minus 1.4 j, 10 minus 1.4 j. Again, someone please tell me what is this thing in its polar form. What is this thing in its polar form? Okay, 0.08 at an angle minus 82 degrees. I am just approximating. So this capital IR2 in its polar form is going to be 0.08 at an angle minus 82 degrees. Okay, 0.08 at an angle minus 82 degrees amperes. Of course, amperes. Okay, so that's all. These are the two current components through the 10 ohm resistor. Previously we found IR1 to be 0.811 at an angle minus 77 degrees, and now we find the current through 10 ohms as what? 0.08 at an angle minus 82 degrees. So what is the net current flowing through the 10 ohm resistor? Can we add the two phasor currents IR1 and IR2? Please say yes or no. Superposition means what? In the end we should add the two results. Yes or no? IR1 and IR2. Yes or no? Very good. We cannot add. We should not add the two phasors IR1 and IR2 because both are not at same frequency. If you recall, I told you what? You can add or subtract two phasors only if both the phasors are at same frequency. Yes. So definitely you cannot add IR1 and IR2. What happened? Okay. Sorry. You cannot add IR1 and IR2. Then how will you proceed? Please type in the chat box. How will you proceed? How do you find the net current flowing through the 10 ohm resistor if you cannot add the two results, that is what? Capital IR1 and capital IR2. Okay. Okay, before that, let me write that point. Capital IR is not equal to IR1 plus IR2. The reason being because IR1 and IR2 are not at same frequency. You cannot simply add the two phasors. Please tell me. Yes, we cannot add the two phasors IR1 and IR2. Then how will you find the net current? We add it in time domain. That's very good. So we have to convert each phasor into what? Time domain, and then add the two results in time domain. Okay. Do not add the two phasors, but rather you convert each phasor into its time domain representation, and then you add the results in time domain. Okay. So convert IR1 into what? Small IR1 of t, and also IR2 into what? Small IR2 of t, and then you add small IR1 of t and small IR2 of t, so that you will get, one second, so that you will get the net current flowing through the 10 ohm resistor. Okay. Now let us go back to the two results that we got for the current through the resistor. First is what? IR1. What is IR1? 0.811 at an angle minus 77 degrees, and this phasor is defined at what frequency? Please keep in mind that this phasor is defined at a frequency of 3 radians per second at omega equal to what? 3 radians per second. Okay. 0.811 minus 77 degrees angle at 3 radians per second. So here IR1 is what? 0.811 at an angle minus 77 degrees amperes at 3 radians per second. So can't we directly convert this into time domain? 0.811 is going to be the amplitude. So 0.811 cos omega t, because the phasor is what defined at 3 radians per second, omega t is going to be 3t minus 77 degrees amperes. That's all. This is what capital IR1. And we can also convert the other phasor into its time domain representation. What is the other result that we got? IR2. IR2 is what? 0.08 at an angle minus 82 degrees amperes. Again, this phasor is defined at a frequency of what? 5 radians per second. Okay, so this is at omega equal to 5 radians per second, 0.08 at an angle minus 82 degrees amperes at 5 radians per second. Okay, 0.08 at an angle minus 82 degrees amperes at what frequency? At 5 radians per second. Again, you convert this phasor into time domain, it becomes what? Small IR2. So is it not going to be 0.08 cos of omega t, which is phi t minus 82 degrees amperes? That's all. So small IR1 of t and small IR2 of t. Now we have the final expression for IR of t. So what is IR of t going to be? It is this thing, 0.811 cos 3t minus 77 degrees amperes plus 0.08 cos phi t minus 82 degrees amperes. Is it clear? This is how you get the net current flowing through the resistor as a function of time. So initially we did the analysis in the phasor domain, and because both the sources are not at same frequency, we have no other option but to use superposition. And when we do superposition, we will get the phasor current flowing through the resistor due to each individual source. But then because the sources are not at same frequency, in the end we cannot simply add the various phasor currents through that resistor. Instead, we should convert each and every phasor into its time domain representation and add the results in the time domain but not in the phasor domain, because both the phasors in this case are not at same frequency. You cannot simply add the two phasors. Convert each phasor into its time domain representation like this. So capital IR1 converted into what? Small IR1 of t. Capital IR2 also converted into what? Small IR2 of t. Then we added IR1 of t and IR2 of t to get the net current through the 10 ohm resistor. Okay, so this current, this component is due to what? The current source which is at 3 radians per second, whereas this component is due to the current source which is operating at 5 radians per second. This is what? Superposition. So the important takeaway from this point is what? The circuit can be driven by multiple sources operating at different frequencies. In that case, we should go for superposition, but do not add the results in phasor domain, add the results only in time domain. Yes, do not add the results in phasor domain. When the sources are not at same frequency, add the results only in time domain. Convert each phasor into what? Time domain, then add all the results in time domain. I hope this is clear. Okay, let's take up one more example. So in this circuit, you should find the loop current I of t. Is it not the loop current? By the way, is it not a single loop circuit? In a single loop circuit, what is same for all the elements? Current will be same for all the elements, and that current will be what? The loop current I of t. And this circuit contains what? A resistor an inductor and a capacitor all connected in series across what? A combination of two different sources. One is what? A DC source whose value is what? 5 volts. The other one is what? An AC source whose value is what? 10 sin t. Okay, they should be volts, I'm sorry. This is 10 sin t volts, okay. So both the sources clearly are not at the same frequency. Whenever both the sources are not at same frequency, we should go for superposition, okay. So first, what is I of t due to the DC source? What is I of t due to DC source? If you are finding I of t due to DC source, it is understood that only the 5 volt source is going to be present, whereas this voltage source, the sinusoidal voltage source will become what? 0 or short circuit. Now what is the operating frequency of the circuit when only the DC source is present? Will it not be 0? Yes. First of all, omega is going to be 0 radians per second. Now due to the DC source, by the way, you should find what? I of t at steady state. You should find I of t at steady state. Now due to the DC source, circuit will reach what? DC steady state. You know at DC steady state, cap is what? Open, inductor is what? Short. When the cap becomes open, the loop also becomes what? Open, no current will flow. So what is the current in the circuit at DC steady state? At DC steady state, because the cap becomes what? Open, no current will flow. So I of t due to DC source, it is what? 0. I of t due to DC source, it is what? 0 at DC steady state. Now the only other current is what? The current due to the AC source. What is the current due to the AC source? If you are finding current due to the AC source, only the AC source is going to be active. The DC source will become short circuit. Yes, DC source will become short circuit. Now we are finding I of t due to AC source. I of t due to AC source. If you are finding I of t due to AC source, like I said, this current source, this DC voltage source will become what? Short. What is 10 sin t? See, 10 sin t, what is the operating frequency? What is the operating frequency? Is it not 1 radians per second? Because 10 sin omega t is what? T, omega is what? 1 radians per second. Omega, it is what? 1 radians per second. Now at this operating frequency of what? 1 radians per second, what is the impedance of inductor? What is the impedance of capacitor? We are doing analysis in the phasor domain, okay? Replace every element with its impedance value. So J into omega into L, J into 1 into 2. So is it not going to be J2 ohms? Again for the 1 farad capacitor, it would be 1 by J omega C. Omega is 1, C is also 1. So is it not simply 1 by J? 1 by J is what? Minus J ohms. Now what is the net impedance in the loop? What is the net impedance in the loop? 1 plus J2 minus J. 1 plus J2 minus J. Is it not 1 plus J? So the net impedance around the loop is what? 1 plus J ohms. 1 plus J ohms, okay? So I of t, is it not going to be, see 10 sin t divided by 1 plus J. See, strictly speaking, I should not be writing this equation, okay? I mean, part of the equation cannot be in time domain, the other part cannot be in, the phasor domain, because 10 sin t is what? Time domain. 1 plus J is what? Impedance, right? Which is in phasor domain. Strictly speaking, I should not be able to write this, but it's okay. I mean, we're just finding the current, right? Yes, current is what? Voltage divided by impedance, okay? What is 1 plus J in polar form? 1 plus J in polar form is what? Root 2 at an angle 45 degrees, okay? So this can be written as 10 sin t divided by root 2 times angle 45 degrees, okay? That's all. 10 by root 2 is what? 5 root 2, and then sine of t minus 45 degrees amperes. That's all. So I'm just bypassing the method where we convert the voltage source into its phasor form, and then we do the analysis in phasor domain, and then again convert the current into our time domain. Instead of doing all that, directly I am writing I of t. That's the only thing. Even if you go by that method, you will get the same result. Okay, end result will not change. 5 root 2 sine t minus 45 degrees amperes. Understood? Yes. So, but in the end, we should add the two results in what domain? In the time domain. We should add the two results in the time domain. What is I of t due to the 5 volt source? It is 0 at steady state. It is what? 0. What is I of t due to the 10 sin t volt sinusoidal source? It is 5 root 2 sine of t minus 45 degrees. If you add the two results, that is what? This I of t and this I of t. 0 plus anything is what? The same thing. That's all. So find I of t at steady state. So I of t is going to be 5 root 2 sine of t minus 45 degrees amperes. I hope the method is clear. Okay, I just found I of t due to each individual source at steady state, and then in the end we just added all the I of t's. Okay, so this is what a series RLC circuit. Do you all agree with that? Clearly R, L and C, all three are connected in series across what? A sinusoidal voltage source. What is given for the sinusoidal voltage source? They simply gave 200 volt RMS. 200 volt RMS. It means what? It is actually 200. Okay, let me write it properly. So this actually means what? 200 at an angle 0 degrees volts RMS. So what is this 200 volts? It is the RMS value of the voltage of this sinusoidal voltage source. 200 volts is what? RMS value of the voltage of this sinusoidal voltage source. 0 degrees is what? The phase angle of the input sinusoidal voltage source. Now you know XL and XC are what? The reactances of the inductor and the capacitor. Yes or no? What is impedance of inductor? J omega L. Omega L is going to be what? XL. So here XL is what? Omega L. And omega L, is it not positive? Always XL is going to be positive. XL, inductive reactance is what? Positive. Capacitive reactance is what? Negative. So XL, which is what? Omega L, it is 20 ohms. So what is ZL? Will it not be J times XL, which is J times 20 ohms? And what about XC? XC is what? The capacitive reactance. What is the capacitive reactance? What is the impedance of capacitor? 1 by J omega C. 1 by J omega C is same as what? J times minus 1 by omega C. J times minus 1 by omega C. That minus 1 by omega C is what is called the capacitive reactance. Okay, so XC is always what? Negative and equal to what? Minus 1 by omega C. In this case, it is given that mod XC is also what? 20 ohms. Mod XC is what? 20 ohms. So, and we already know XC is what? Negative. So what is the actual value of XC? 20 or minus 20? Because XC we know is what? Going to be negative. The value of XC is going to be minus 20 ohms. Only then mod XC can be 20 ohms. So XC is what? Minus 20 ohms. Again ZC is what? The impedance of the capacitor. Impedance of the capacitor will be what? J times the reactance of the capacitor. Yes or no? J times XC. So is it not minus J20 ohms? Yes. Now let the loop current, let the phasor loop current be some I. Okay. So now what is I going to be? Capital I is going to be what? Is it not the applied phasor voltage divided by the net impedance in the loop? Yes or no? Applied phasor voltage is what? 200 volts RMS. 200 volts RMS divided by the net impedance in the loop. What is the net impedance in the loop? R plus ZL plus ZC. Yes or no? Divided by R plus ZL plus ZC. What is ZL plus ZC? ZL is what? J20. ZC is what? Minus J20. ZL plus ZC is what? J20 minus J20. Is it not 0? So ZL plus ZC is what? 0. So what is the only thing that will remain in the denominator? It is just R. And what's the value of R? R is what given as 10 ohms. So 200 volt RMS divided by 10 ohms, is it not going to be 20 amperes? Simply 20 amperes or 20 amperes RMS? RMS, because voltage is in RMS terms, even the resulting current is going to be in RMS terms, okay? So this is going to be 10 amperes RMS. Again, 10 amperes RMS is same as what? 10 at an angle 0 degrees amperes RMS. But the question is what? To find capital VC. Capital VC is what? The phasor voltage across the capacitor. Yes. So capital VC, phasor voltage, remember the same loop current also flows through what? The capacitor. Phasor voltage across any element would be equal to what? The phasor current through that element multiplied with impedance of that element. Phasor current through C is what? Capital I. Should it not be multiplied with ZC? It should be multiplied with the impedance of the cap, which is what? ZC. That's all. So I is what? 10 at an angle. Let me write this cleanly. So I, which is what? The loop current, is what? 10 at an angle 0 degrees amperes RMS times ZC. What is ZC? Minus J20. Minus J20. Minus J20 ohms. Again, amperes RMS into ohms. Amperes into ohms. Is it not volts? Volts or volts RMS? Volts RMS, because current again is in RMS terms. The resulting voltage would again be in RMS terms, okay? And then 10 at an angle 0 degrees is what? Just 10. 10 into minus J20. 10 into, is that correct? Oh, it is 20, right? I'm sorry. The current, because R is what? 10, 200 by 10 is what? 20. So this is what? 20. So here also it should be 20. So 20 times 20 is what? 400. So 400 minus J, 400 minus J. Minus J is what? Angle minus 90 degrees. And then voltage, right? Volts RMS. This is the final answer. VC. So what is VC? 400 at an angle minus 90 degrees volts RMS. Understood, right? 400 at an angle minus 90 degrees volts RMS. Or you can write it as minus J400. Minus J400 volts RMS. Both are one and the same. Minus J400 volts RMS. But this is the actual polar form representation of the phasor voltage across the capacitor. 400 at an angle minus 90 degrees volts RMS. Is it clear? Yes. So we have to solve a few more problems on AC analysis. So today evening we will take up that problem solving session. Then AC analysis would be, or we'll get started with a new topic. So evening we'll solve a few more problems related to AC analysis. Okay.